Our next question deals with some true or false statements. For each statement, say whether it's true or false and justify your answer. And you'll see 2 marks, 3 marks, 2 marks. We do need an explanation. Firstly, the straight lines, these things are parallel. So we need to find the gradient of each line. Well, we're going to rearrange these lines into the form y is mx plus c and then write down what our gradient is. For my first line, I divide everything by 3. Y is 1/3 x plus 2. So my gradient is 1/3. For my second line, y, again divided by 3, is 1/3 x subtract 1. My gradient is 1/3. So this, therefore, is true. And my justification is their gradients are the same. Second, the straight lines, these two straight lines are perpendicular. Similar argument, I need to show that the gradients now are negative reciprocals of one another. Again, we're going to go in the form y is mx plus c. So this needs a slight rearrangement to y is negative 2x add 5. You might not feel a need to do that, but it helps us to structure our answer. I'm going to divide by 2 to get y is equal to, again, and this time negative 1/2 x plus 1. And so I want to see if these two gradients, so m1 is negative 2, m2 is negative 1/2, if they are negative reciprocals of one another. Now you can probably see already they are not negative reciprocals, because indeed both of them are negative. They are reciprocals of one another, not negative reciprocals. And I would want to write that. Therefore this is false. The other way you could do this, and some textbooks prefer this, is if they are perpendicular, then the product of the two gradients is negative 1. Well, negative 2 multiplied by negative 1/2 is positive 1, so therefore that doesn't work either. They are not perpendicular. Third, the curve of that meets the x-axis at exactly 1 point. Well, if we think about a graph, the x-axis is everywhere that y is equal to 0. In other words, in this case, where x squared subtract 6x add 9 equals 0. So I need to solve this equation here. Now, I might be able to see how to factorise this. It factorises to x subtract 3 all squared. If not, then I can use my old trick. I can say AC is 9 and B is negative 6. I want a number that multiplies to give 9, adds to give negative 6. Well, that's negative 3 and negative 3. And then write that as x squared subtract 3x subtract 3x add 9. So I have factorised my first two terms, x subtract 3. And then I want this to be x subtract 3 as well. So that would be negative 3. And so I have x subtract 3. And I'm left with x subtract 3. Exactly the same thing in either case. And this means x equals 3 twice. There is only one solution. So it meets the x-axis exactly 1 point. Yes, that's where x is 3. True. And again, I've got a very clear justification. Question 12 asks you to show that this triple bracket can be expanded to give these results for all values of p where m and n are integers to be found. So I'm just going to expand my left-hand side and see what I end up with. And basically, they've just given me a way of checking my answer. It doesn't really matter what we expand first, but I'm going to pick these second and third brackets because there's no coefficient on the p. It will make my life a bit easier, I suspect. So I'm going to leave my 2p plus 1 where it is, and I'm going to multiply these two brackets. P squared, subtract p, add 4p, so add 3p. Negative 1 multiplied by 4 is negative 4. Then I need to expand again. I'm going to do 2p multiplied by all these things. So I get 2p cubed, add, and then 6p squared, and then subtract 8p. And I'm going to do 1 multiplied by all these things, add p squared, add 3p, subtract 4. That add 1 is a nice thing for them to have put in here. Then I group my like terms. 2p cubed remains where it is. 6p squared add p squared is 7p squared. Negative 8p add 3p is negative 5p. And I've just got subtract 4 on the end. And I can just check, well, 2p cubed matches, m must be 7, negative 5p matches, n is negative 4. So I'm pretty confident in that in the exam. Question 13, Marcus says if you increase a number by 20% and then take the answer and decrease it by 20%, you don't get the number back where you started. Is Marcus correct? Explain how you know. Well, Marcus is correct. This is one of the most common misconceptions. And the reason Marcus is correct is when you increase it by 20%, that's 20% of the original, whereas when you decrease it by 20%, decrease the final result by 20%, that's 20% of the new value, and those 20% aren't the same. So we could just write that. Increasing involves 20% of original. Decreasing involves 20% of final value or new value. These aren't the same. Sorry, these aren't the same. Therefore, don't get back to where you started because you're decreasing and increasing by different amounts. Now that's what they're looking for in the mark scheme. I think in an exam you might want to illustrate your point just to cover all your bases with a simple example. So you might say, I have £100, I increase by 20%, I get to 120. But then if I try to go back, well, I'm subtracting 24. So I added 20 here, but then I would subtract. 12 is 10%, so 24 in total, which is 96. Now that's not where the marks are allocated here, but I think it just helps us structure our thoughts a bit better. We're increasing and decreasing by different amounts. And they'll be suitably generous in the mark schemes for this, because it's quite hard to articulate what you mean. And that's the next few questions dealt with.